The F-22 Raptor is a fifth-generation air superiority fighter that is considered fourth-generation in stealth aircraft technology by the USAF. It is the first operational aircraft to combine supercruise, supermaneuverability, stealth, and sensor fusion in a single weapons platform. The F-22 has clipped diamond-like delta wings blended into the fuselage with 4 empennage surfaces and leading-edge root extensions running to the upper outboard corner of the carrot inlets. Flight control surfaces include leading-edge flaps, flaperons, ailerons, rudders on the canted vertical stabilizers, and all-moving horizontal tails. For speed brake function, the ailerons deflect up, flaperons down, and rudders outwards to increase drag. The aircraft has a refueling boom receptacle centered on its spine and retractable tricycle landing gear as well as an emergency tailhook. The aircraft's dual Pratt & Whitney F119 augmented turbofan engines are closely spaced and incorporate pitch-axis thrust vectoring nozzles with a range of plus or minus 20 degrees. The nozzles are fully integrated into the F-22's flight controls and vehicle management system. Each engine has maximum thrust in the 35,000 lbf class. The F-22's thrust-to-weight ratio at typical combat weight is nearly at unity in maximum military power and 1.25 in full afterburner. The carrot inlets generate oblique shocks with the upper inboard corners to ensure good total pressure recovery and efficient supersonic flow compression. Maximum speed without external stores is approximately Mach 1.8 at military power and greater than Mach 2 with afterburners. The F-22's high cruise speed and operating altitude over prior fighters improve the effectiveness of its sensors and weapon systems, and increase survivability against ground defenses such as surface-to-air missiles. The ability to supercruise, or sustain supersonic flight without using afterburners, allows it to intercept targets that afterburner-dependent aircraft would lack the fuel to reach. The use of internal weapons bays permits the aircraft to maintain comparatively higher performance over most other combat-configured fighters due to a lack of parasitic drag from external stores. The F-22's thrust and aerodynamics enable regular combat speeds of Mach 1.5 at 50,000 feet, thus providing 50% greater employment range for air-to-air missiles and twice the effective range for DAMs than with prior platforms. Its structure contains a significant amount of high-strength materials to withstand stress and heat of sustained supersonic flight. The F-22's aerodynamics, relaxed stability, and powerful thrust vectoring engines give it excellent maneuverability and energy potential across its flight envelope. The airplane has excellent high alpha characteristics, capable of flying at trimmed alpha of over 60 degrees while maintaining roll control and performing maneuvers such as the Herbst maneuver and Pugachev's Cobra. The triplex redundant fly-by-wire control system and full authority digital engine control (FADEC) make the aircraft highly departure-resistant and controllable, thus giving the pilot carefree handling. The aircraft has an integrated avionics system where through sensor fusion, data from all onboard sensor systems as well as off-board inputs are filtered and processed into a combined tactical picture, thus enhancing the pilot's situational awareness and reducing workload. Key mission systems include Sanders or General Electric and/or ALR-94 electronic warfare system, Martin Marietta and/or AR-56 infrared and ultraviolet missile launch detector, MLD, Westinghouse or Texas Instruments and /APG-77 active electronically scanned array, ASA, radar, TRW communication, navigation, identification, CNI, suite, and long-range advanced IRST currently being tested. The F-22's baseline software has some 1.7 million lines of code, the majority involving the mission systems such as processing radar data. The integrated nature of the avionics, as well as the use of ADA, has made the development and testing of upgrades challenging. To enable more rapid upgrades, the avionics suite added an Open Mission Systems processor, as well as an open-source Kubernetes platform called the Open Systems Enclave to enable the use of containerized software from third-party vendors. The F-22's ability to operate close to the battlefield gives the aircraft threat detection and identification capability comparative with the RC-135 rivet joint, and the ability to function as a mini AWACS, though its radar is less powerful than those of dedicated platforms. This allows the F-22 to rapidly designate targets for allies and coordinate friendly aircraft. Data can be transferred to other aircraft through a BSEN or via Link 16 using MIDS JTRS. In 2007, the F-22's radar was tested as a wireless data transceiver, transmitting data at 548 megabits per second and receiving at gigabit speed, far faster than the Link 16 system. The radio frequency receivers of the Electronic Support Measures System give the aircraft the ability to perform intelligence, surveillance, and reconnaissance tasks. The APG-77 radar has a low observable, active aperture, electronically scanned antenna with multiple target track while scan in all weather conditions. Radar emissions can also be focused to overload enemy sensors as an electronic attack capability. The radar changes frequencies more than 1,000 times per second to lower interception probability and has an estimated range of 125 to 150 miles against an 11 square feet target and 250 miles or more in narrow beams. The upgraded APG-77V1 provides air-to-ground functionality through synthetic aperture radar mapping and strike modes. Alongside the radar is the ALR-94 electronic warfare system, among the most technically complex equipment on the F-22, that integrates more than 30 antennas blended into the wings and fuselage for all-round radar warning receiver coverage and threat geolocation. The aircraft has also been upgraded to incorporate an automatic ground collision avoidance system. The F-22 has a glass cockpit with all digital flight instruments. The monochrome head-up display offers a wide field of view and serves as a primary flight instrument. Information is also displayed upon 6-color liquid crystal display (LCD) panels. The primary flight controls are a force-sensitive side stick controller and a pair of throttles. The canopy's dimensions are approximately 140 inches long, 45 inches wide, and 27 inches tall and weighs 360 pounds. The F-22 has integrated radio functionality. The signal processing systems are virtualized rather than as a separate hardware module. The Integrated Control Panel (ICP) is a keypad system for entering communications, navigation, and autopilot data. Two 3-inch x 4 and up front displays located around the ICP are used to display integrated caution advisory, ICAW, data, CNI data, and also serve as the standby flight instrumentation group and fuel quantity indicator for redundancy. The standby flight group displays an artificial horizon for basic instrument meteorological conditions. The ejection seat is a version of the ACES II commonly used in USAF aircraft. With a center-mounted ejection control, the F-22 has a complex life support system, which includes the onboard oxygen generation system, protective pilot garments, and a breathing regulator valve controlling flow and pressure to the pilot's mask and garments. The pilot garments were developed under the Advanced Technology Anti-G Suit project and protect against chemical or biological hazards in cold water immersion, counter G forces and low pressure at high altitudes, and provide thermal relief. Following a series of hypoxia-related issues, the life support system was consequently revised to include an automatic backup oxygen system and a new flight vest valve. In combat environments, the ejection seat includes a modified M4 carbine designated the GAU-5.